Film and cameras are the subject. On this videotape, we'll define types of film and formats, demonstrate cameras which use those films, then we'll demonstrate some techniques for inspection and service. During the videotape, we'll be using a wide variety of cameras and films. Photographic film, or light-sensitive material, came on the scene before cameras, but first we're going to define what a camera is. Every camera, regardless of whether it's a digital camera or a film camera, has four basic parts. First, there is a way to gather light, and in this case, in most cases, it's a lens. We can take it off this camera just so you can see that. But this is the light gathering device. That's part one of any camera. The second important part of a camera is a way to hold the film or whatever light sensing device is used. In this case, the film is held in the film compartment and with a 35 millimeter. In this case, it runs along these rails. That's the second important part of any camera. Third, there has to be some way to stop and start an exposure. In this case, it's a shutter. You see it's open, the exposure is being made. When the shutter is closed, there's no exposure. And finally, there has to be a box of some sort, called the camera body in this case, which holds the whole system together. When a shutter opens, the lens projects an image onto film, and in case of 35 millimeter film, there are three basic types. First of all, and most popular, are the color negative films. I'm just holding one example of that here. There is black and white film, and there is color transparency film. Now within each of these classes, or general classes, there's a whole group of subclasses. For example, there are many varieties of color negative film, both with sensitivity, speed, and also color temperature. Black and white films have a wide variety. They are used in medical use, lithography, and many other applications. And color transparency film is also widely used and has various color hues, also many film sensitivities. And while we're talking about film sensitivity, that is a number which you see here. I'm pointing to that. In this case, it's 400. On the film next to it, the black and white film, that number is 100. Over here, this is a 200 film. I have my thumb or finger right in the way. ISO numbers are international standards numbers, and they relate to the sensitivity of film to light. In other words, a 400 film will be twice as sensitive as a 200 film, and a 200 film twice as sensitive as a 100 film. ISO numbers follow multiples of 2, and the normal range for consumer film or photographic film would be from 25 through 1600, although there are some on either end of that scale. The ISO numbers, by the way, are the same as the older ASA numbers you may have seen. You might ask why not use the fastest ISO or the largest ISO number so you'd always have the maximum sensitivity to light, but there is a trade-off. The higher the ISO number, the larger the grain size and the less sharp the image will be. In other words, an ISO 100 film will produce a much sharper image, ultimately, than an ISO 400 film. .35 millimeter film originated in the motion picture industry, and it's called 35 millimeter film because it is 35 millimeters wide. In other words, if I put this metric ruler on here, you'll see the width of a roll of film is 35 millimeters. Also, as it turns out, the frame width, which is 8 perforations, works out to about 35 millimeters, but not exactly. But do remember this, there are exactly 8 perforations from one frame to the next, and that's how film is metered. Cameras meter film or count frames two different ways. One is mechanical, and that is using a sprocket which counts off literally 8 perforations on the 35 millimeter film. This is a sprocket in a typical 35 millimeter camera. Some of the newer electronic cameras use photodetectors to do exactly the same thing. This is a compact camera, and you'll see this device here with 2 little windows in it. That's also looking at the sprocket perforations in the 35mm film and counts 8 for each frame. Modern cameras can read the ISO number and also number of exposures per roll from a code called the CAS code, which is on each cassette. If the cassette has the DX symbol, it will have that, and that is a code which you see here. This may not look like a code, but if you orient the cassette as it normally would be at the bottom, you'll notice this is metallic and would conduct electricity. This is painted over and does not conduct, and so you have series of conducting and non-conducting surfaces which the cameras can detect. And notice that this is different for different ISO numbers. The ISO code is on this side of the cassette, and you'll notice that there is a difference in the pattern between these two cassettes, and also as I bring in this third one, all three are different ISO numbers, all three have different patterns, all three have different numbers of exposures. The camera does this through something called DX contacts. If you see a double row of DX contacts in a camera, and you will see this on more expensive cameras, then it can read not only the ISO number, but also the number of exposures on a roll and the film latitude. Less expensive cameras, compact cameras, may have just a single row of DX contacts. They are reading only the ISO number. One more consideration before leaving ISO and DX contacts. Certain cameras have 4 or less, and this particular one has 4, DX contacts. You'll see some with 3 and some with even 2. Those cameras cannot read a wide variety of DX codes and therefore generally do not expose slide film well. It's not recommended that you use slide film with cameras which have DX contacts 4 or fewer. On the other hand, the more sophisticated cameras, as this one is, have 5 or sometimes 6 DX contacts on the ISO side, and also, as we said, they can read the contacts here, which determine the number of exposures per roll, and also film latitude or film range, exposure range at the top. .35mm cameras can generally be divided into 2 wide categories. That is what we call the lens shutter or compact cameras, those which do not have interchangeable lenses, and the single lens reflex camera, which we'll look at in a few moments, which does have interchangeable lenses. The compact camera or lens shutter camera come in a variety of sizes, shapes, and descriptions. The lower end type would be fixed focus and with a single focal length lens. That is, the lens may be a 28mm or a 35mm lens. It may or may not have autofocus. If it says focus free, the chances are it has no autofocus system built in. The next step up in complexity for the 35mm lens shutter cameras are those which are the tele-wide, which have 2 focal lengths. We'll turn this one on. This particular one has a 28mm, which is a fairly wide angle position, and a 45mm, which is a normal shooting position. Now, these cameras have only those 2 positions. In other words, these aren't zoom cameras. They only change from one focal length to the next. Lens shutter zoom cameras are the next step up, and there's a wide variety of those. This is a very compact model, but all of these cameras have continuous zoom lenses. In other words, the lens can be extended in an infinite number of steps, usually between the near focal length, which is 28mm in this case, to 70, which would be a good portrait length in that case. The most complex of lens shutter cameras are those which view through the taking lens like a single lens reflex, except they have a lens shutter, not a focal plane shutter as a true single lens reflex does, and they do not have interchangeable lenses. However, you are viewing through the taking lens in this case, as opposed to most other lens shutter cameras where viewing is done through a viewfinder lens and taking the actual photograph is made through another lens. Single lens reflex cameras are used by more serious amateur photographers and professional photographers. The 35mm single lens reflex, the example we have here, is a completely manual camera. That is, it has no motors, no autofocus, no auto exposure features. It's a good one to start explaining the attributes of single lens reflexes with, however. Single lens reflex means that when one views or looks at the picture before taking the picture, you're looking through an eye lens which goes through a reflex system in the camera, which involves this mirror, which you see right here, and I can lift that mirror. You can see the shutter behind it. So the image passes through the taking lens, reflects off the reflex mirror you see here, passes through the prism and then to the eye lens. So the operator is actually looking through the same lens that takes the picture. We'll now look at the interchangeable lenses used with single lens reflex cameras. The standard lens for a 35mm camera, or the standard focal length for a lens for a 35mm camera, is 50mm, and that is meaning that from the optical center of the lens at infinity, it's 50mm to the film plane. Also, the 50mm lens sees about what you see with your eye. In other words, it takes in the same field of view that you would with a casual glance, and therefore it's considered to be the standard lens for a 35mm format. That information is printed usually on the lens ring of any lens. This is a 50mm lens. The next number you see, we'll move around here, is the maximum aperture of the lens, or the size of the opening in the glass when the diaphragm blades are fully open. In this case, it's 1.8. The ratio is 1 to 1.8. The next number, obviously, is the serial number of the lens. While we're looking at aperture numbers, you can see them here. The widest aperture is 1.8, and the numbers progress then 2.8, 4, 5.6, 8, 11, 16, and 22. And if we look at the diaphragm leaves, by the way, the opening is referred to as the aperture. The blades, which control the size of it, are called diaphragm blades. If you're in the video business, they're called iris blades. You'll hear both terms used. This is an f/22 aperture. This is a 1.8 aperture. This is an f/5.6 aperture. The right-hand column is a listing of f numbers as seen on most lenses. The numbers at the top represent large lens openings, and the numbers at the bottom represent small lens openings. The numbers in the left column represent the area opening of the lens, where 1 is the largest possible area for a lens, and each successive number is the inverse of half that area. We use square roots of the lens opening area to generate f numbers. Aperture numbers relate to exposure the same way ISO numbers do. In other words, each whole aperture number, like changing from 5.6 to 4, doubles the amount of light, or doubles the exposure. So changing from 5.6 to 4 is equivalent from changing from ISO 100 film to ISO 200 film. On the other hand, when we go from 5.6 to 8, the exposure is cut in half. That would be the same as changing from ISO 200 film to ISO 100 film. Getting back to the camera body, let's have a look at the shutter system on a single lens reflex camera. Normally those shutters are located right at the film plane, and in this case it's a set of blades which travel in the vertical direction. If I cock the camera, you'll see, if you watch, the shutter moving. Notice that as the camera is cocked and the film is moved, one shutter blade always remains closed so that the film does not get exposed. Now I have the shutter set on bulb, or B, and the way a single lens reflex or focal plane shutter works is that first one side opens, this one moving from bottom to top, and then a closing blade moves in and shuts off the exposure. Shutter speeds or exposure times are indicated on this speed dial at the top of the camera. The manual type SLRs, or single lens reflex cameras, will have this type of dial. The electronic or automatic ones, generally these numbers will be displayed in an LCD. This is B for bulb, meaning the shutter stays open as long as the trigger is held or the release button is held. This is 1 second, 1/2 second, quarter second, and on up through 1/4000th of a second. Notice here, these follow the same progression as ISO numbers and apertures. That is, each step represents a factor of 2, either doubling the exposure or cutting the exposure in half. The last consideration on this camera will be depth of field and depth of field preview. A lot of people have questions about that. There is a button on the side of this camera which is called the depth of field preview button, and physically what it does when it's pressed is close the diaphragm to the aperture that you have selected or the photographer has selected to take the picture or make the exposure. And if you look at the scale on the top of the lens, the aperture numbers, 22, 16, 11, and 8, so on, are color-coded. In other words, they're orange, blue, and yellow in this case for those. And if, for example, you had selected a focus distance of 10 feet for the subject, if the lens were set to 1.8, only 10 feet would be in focus. However, if the aperture is closed down, for example, to f11, then you can see at the yellow line the focus goes from 7 feet out to approximately 20 feet. And if the lens were set to f22, the orange number, then the focus, the near focus, would be from about 6 feet all the way to nearly infinity. That gives an indication then of the depth of field, and what the depth of field preview button does is let the viewer or the photographer see with his own eye the actual amount of focus. Electronic single lens reflex cameras have all the same features as the manual, except they are automatic. In other words, the exposure is made automatically, focus is done automatically, and even film transport or winding is usually done automatically with a motor. This particular camera, you can see again the reflex mirror. However, underneath the reflex mirror of an autofocus camera, you'll see a sub-mirror. You can just see that as I raise this with my tweezers. And that reflects a portion of the image that the viewfinder would normally see. It reflects that to the bottom of the mirror box where there is an autofocus sensing device. And that, in turn, communicates with the lens through these contacts, which you see right here, and therefore can create autofocus and auto exposure. Now in this case we're installing a zoom lens onto the single lens reflex camera. Remember, we looked at zoom lenses on lens shutter cameras. This is an example of a zoom lens on an autofocus single lens reflex camera. Notice too that there's a speed dial at the top, which is very similar to what you would see on the manual camera. However, there's also a choice here called P, or program, which means that all the exposures can be made automatically. This camera also features a built-in flash, and I'm going to cover the lens so it's dark, and when the release button is pressed 1/2 stroke, you notice the flash pops up. So these cameras will do automatic flash exposure. Lenses for single lens reflex cameras come in a variety of shapes and sizes. What we have here aligned on the table are the one you have just seen, which is the manual focus 50 millimeter lens. Alongside it is another 50 millimeter 1.8 lens, but this is autofocus, and you can see the difference in the size of these two lenses. There's just more inside of an autofocus lens. There has to be circuit boards and other things. And so typically the autofocus lenses will be a little bit larger, bulkier. However, the amount of glass in them will be just exactly the same. If they're both 50 millimeter 1.8 lenses, then the maximum aperture and the way the diaphragm works is exactly the same. Here is an example of a single lens reflex zoom lens. This particular one has a focal length range from 28 to 105, which would be about portrait length, and 28 is about wide angle. The relationship between focal length and what you see, or the image, is this. At 50 millimeters, we're looking at the standard lens for a 35 millimeter camera. If the focal length is doubled, for example, to 100 or 105 in this case, that means objects will appear twice as close. And on the other hand, if we go down to 28 millimeters, objects will appear about twice as far away. This is considered wide angle, and this is considered telephoto. There are lenses which get much more telephoto, as in the case of this one. The range on this particular lens is from 100 millimeters to 300 millimeters, which would bring objects 6 times closer. It would seem reasonable to ask then, what's the difference between a 35 millimeter single lens reflex zoom lens and the zoom lens on a lens shutter camera? They're both, for example, in this case, this is a 28 millimeter lens on the lens shutter camera, and it zooms out to 70 millimeters. This is a 28 millimeter lens and zooms to 105 millimeters. But you can see there's a huge difference in the size of the lenses, the amount of glass, the amount of light gathering ability. The big difference is simply that this has a maximum aperture of f3.5, whereas a camera like this would have a maximum aperture more like f8 or f5.6, depending on the focal length. There is a relationship for a given size of glass, and this happens in zoom lenses, between the focal length and the amount of light gathering ability. The wide angle lenses will gather more light than telephoto. So as it is zoomed to telephoto, the maximum aperture of the lens decreases, and you will see this indicated then usually on the ring of the lens. In other words, it says that the maximum aperture is 3.5 to 4.5, meaning that at wide angle it's a 3.5 maximum aperture lens. At telephoto, the maximum aperture is f4.5. A lens shutter zoom camera, particularly a compact one set to 70 millimeters, such as this one is, and a single lens reflex zoom lens set to 70 millimeters, will produce exactly the same picture content. In other words, when you take a picture of a subject, it will appear the same with this lens as with this lens as far as content goes. However, this larger lens can gather a lot more light and can take pictures in much lower light without the need of a flash. Also, because of the mechanics and the optical glass quality, generally the picture will be sharper with the single lens reflex zoom than with the lens shutter zoom. APS, or Advanced Photo System, differed significantly from 35 millimeter, but it's mainly in the film format and not so much in the cameras, although we're going to look at the cameras in a moment. This is an APS cassette. You'll notice that the information which is on it is similar to what we've seen with 35. That is, the ISO number remains in the same type of nomenclature. This is 200. This happens to be a 40 exposure roll. The number of exposures per roll, or standard number of exposures per roll, will be 15, 25, and 40 rather than 12, 24, and 36 as with 35. Notice also that each cassette contains an ID number, and this will relate to a barcode which we'll see later on the proof sheet. At the end of the cassette, or the bottom end of the cassette, there are 4 icons. One of those is illuminated white here, and that is the full or circular icon, which means this is an unused cassette. If we move in the direction of the arrow, we go to a partially used cassette, a fully used cassette, and a processed cassette. The camera will set these 3 conditions. In other words, if in certain cameras, if you use the mid-roll rewind, you will come out with a partially used cassette icon. If you shoot the entire roll of film, this white dot will have moved over here to indicate this has been a used cassette. When the cassette is returned from the processor, and by the way, the film remains inside the cassette throughout its life. When it returns from the processor, it will be set here to indicate this film has been used. At the other end is the code, the same as the DX code or the CAS code on 35mm cassettes. However, this was in a rotational fashion. In other words, rather than being conducting and non-conductive, this has reflectivity and non-reflectivity, and the spool rotates as the film turns and gives information about ISO number and number of exposures. Also, at this end, where normally you would see film coming out of a 35mm cassette, you see a light-tight door. Now let's look at the APS film and see what the differences are between it and 35mm. We're going to open the cassette, and I'm going to use a little tool here. And by the way, all the operations on the cassette are done at what would be the top end of the cassette as it goes into the camera, which is the end where the encoding is. But we'll insert the tool and open the light-tight door. You can see that just opens and closes. When the door is open, then the spool is unlocked and free to move. When the door is closed, the spool cannot turn without damage to the cassette. And we'll just turn in the direction of forward winding and just bring some film out. And first of all, you'll notice it's a smaller film format than 35. Also, you'll notice there's no real leader on it. It just starts with a slightly clipped end where I am down here. And also no perforations until we get to frame number 1, and then there are 2 perforations at the top. And then following that, for each frame, there are 2 perforations. The film base is thinner than 35mm, and also on the entire back of the film, which you cannot see, but it's there, is a coating of magnetic material. And this can be written to by a magnetic recording head in the camera on the bottom side of the film, and that would be along here, which tells the processor information such as format, also date, other information such as that. On the top edge of the film, there will be information written by the processor. When a cassette is first placed inside of an APS camera, the first thing the camera does is open the light-tight door. In other words, it will turn this and open the light-tight cover, and that will, as we said, release the spool to be turned. It will then turn in the rewind direction, and you notice as I do this, we can change the position of the status icon. And what happens is when the film is rewound after exposure back into the cassette, the camera continues to run until it positions this icon, for example, for exposed or perhaps for partially exposed film. Then the camera stops, closes the door, and it's locked into that position. As was mentioned, APS cameras differ very little from 35mm cameras of the same family. I have 2 examples here of compact or lens shutter APS cameras. This is what would be considered a low-end model, which has fixed focus. It does have a motor drive, however, to load the film. It has to have that. However, it has no magnetic encoder. It does optical encoding. And the 3 APS formats, which we'll show you in a moment when we look at the prints, are the selection switch is back here. If we move to a lens shutter zoom camera, and I'll just open this lens, this is very similar in operation and appearance to a compact 35mm zoom. The basic difference is that it is complete drop-in loading. In other words, if we open the film compartment, you notice that the back of the camera does not open to expose the film rails. The cassette merely drops in like this. The door is closed and the camera takes over, and you'll hear it back winding to read the cassette, and now it's forwinding to push the film out into the film aperture to the number 1 position, and it says that we have 40 exposures remaining. You see it's read that off of the cassette code. The date is set, and we're ready to take pictures. There are 2 significant operational differences between APS cameras and 35mm cameras. And the first is in the selection of format for the color print. We have three to choose from. C, which is classic, which would be a print made to a classic format, same as 35. H is the high definition TV format, and P, which is panorama format. It's interesting to note, though, that each picture is taken full frame, which is the H format. And we'll show you exactly what that is in a few moments when we look at some exposed negatives. The C merely crops that, and the P crops it a different way for panorama. This information is given to the film through the magnetic head that's in the camera. Or in the case of the lower end cameras, that's done optically through a switch here on the bottom, which puts an optical code along the bottom of the film. The second change we've already mentioned, or difference, is that there is a magnetic head in the camera. And we have here an APS camera which has the back cover removed so you can see what would be the pressure plate for the film. The film cassette is over here. The film runs underneath this pressure plate, and the spool or take-up spool side is over here. This is the magnetic head, and we've detached that so you can see it, but it's a small tape recorder type head that imprints a code along the bottom edge of the film on the back side where the magnetic coating is, and that tells the processor print format and date. When APS film is returned from processing, one received prints plus an index print, as it's called, which I'm holding here in my hand, and that shows you one nearly contact size print of each negative, each frame on the film. They're numbered, as you can see, and also you'll see there are some white lines, some faint white lines here. What this is you can see that where there is a line indicated, that means that classic or C was selected and the print was made within these white boundaries. But the entire negative is still available if you choose to change later on. In other words, this could be converted to a panorama shot later. It could also be converted back to the H or HTV or high definition TV format. Let's look at some APS negatives, actual ones, and we'll turn some of these out of the cassette, and we'll just come up with these same negatives. And you can see, I'm going to turn this over to give a little background. You can see the size of these negatives, and I'm going to bring in next to them some 35 negatives. In other words, the 35 is significantly larger, although the APS negative is almost as long. Another feature of APS is that the cassette, which has the serial number, we showed you that before, that serial number is carried over to the index print. And also there is a barcode here for automatic reading. That barcode would represent this serial number. So that the two are always kept together. They're easy then to see for the owner. If he picks up an index print, that can be referenced easily to the cassette if reprints are needed. There are special players and scanners for APS which also have drop-in cassette loading, which enables the user to digitize the film, the images on the film, for computer use or for video. Medium format cameras use 120 or 220 roll film. Both of those films are 2 1/4 inches wide. In other words, the width of the negative is 2 1/4 or 6 centimeters wide, and the length depends on whether you get 120 rolls or 220 rolls. How many exposures per roll depends on the medium format chosen, and there are several of those, as we'll show you in this graphic. As you can see, what we have here is a schematic diagram of a 120 roll of film, a part of it, and we've laid out on this several formats, the popular ones. The first one is 6 by 4.5, which is 6 centimeters or 2 1/4 inches by 4.5. In that case, there are approximately 15 exposures for a 120 roll. 6 by 6 is the 2 1/4 square, or 6 by 6 square, which means it's 6 centimeters across, 6 centimeters wide, or along the length. Those are 12 exposures per roll on a 120, 24 exposures on a 220. And then we have 6 by 7, which extends the length, but still the width always stays 6 centimeters, which is what 120 film is. There's 6 by 7, there's 6 by 9, there's several super wides, there's a number of formats, all called medium formats, which use 120 roll film. Medium format cameras are like all the other cameras we've discussed, except they're a little bit larger. They have a lens, or a means of gathering light. They have a film holder, or a way to hold the film. We can take a look at that. There's a slide here, by the way, which protects the film if the film back is removed, and we can take the entire film back away from the camera. This is the film holder in this camera. We can open the film holder, and you can see the 120 roll of film loaded in here. If I take the film holder out, you can actually see the film. But this is a 120 film holder. It happens to be a 6 by 4.5 format. We have a shutter, which is a cloth curtain focal plane shutter, and of course a box to hold the whole system together. Knowing how to do a quick, systematic camera inspection is important. When a customer brings in his or her camera, perhaps for trade-in, maybe to return the camera, or just ask, how's my camera working? Or if they want to bring in a camera for service. One of the first things you'll want to do is check any camera that comes in for impact damage. And we're going to start with a single lens reflex camera here. First thing is just to look the entire body over to look for any obvious signs of impact damage, such as cracks or dents, and we'll show you some of those in a moment. And another thing is look at the general alignment of the camera. This camera looks very good. It's clean. There's not a mark on the outside cover except in one place, which is right here. You see this little nick or dent in the plastic right there, but that should get your attention. And the reason is, if I give you an angle here, you can see that the bayonet mount is lower on this side than it is on this side. This camera has received severe impact with the lens on, and the body is damaged. In fact, the camera may be a complete total loss, although the only mark is right here. The plastic covers on modern cameras are extremely tough and can take a lot of impact damage without much noticeable marking. But here's what to look for. Look at the corners, and you can see a significant amount of impact on this corner, also a small corner crack. That doesn't look too bad, but in order to crack a plastic cover like this in such a fashion, this had to take a very severe hit. Also, look along the edges between the covers and the body for open seams. You'll see this cover has actually been lifted and torn away from its mountings, and there's a wide open seam there along with yet another crack here by the strap lug. This is another indication of very severe impact damage. When inspecting lens shutter cameras for impact damage, you use much the same method. If it's a zoom camera, zoom the lens entirely out and then again look to be sure that the lens is perpendicular to the body in both directions. In other words, it should not be leaning even a little bit one way or the other. An easy way is to look down on top of the camera just to be sure the lens comes straight out. You should also listen to the zoom to make sure, as you hear here, that the motor is steady. It doesn't start and stop or slow down and speed up during the zooming to indicate that there's strain or stress. Again, look around the corners of the body. Look where the screws go into the body, like right here. If there's been impact damage, the chances are one or more of the screw heads will have popped through the plastic and there'll be a slight tear in the plastic here. Also, get used to looking at the seams of a camera which has not been dropped or not been taken apart. They should be tight and very even throughout. In other words, if you look at the seams along the top edge, they should be clean and evenly spaced along the whole camera. If they are, and there's no sign of any damage to the lens, the chances are the camera has not been dropped. The next step in your inspection should be for sand or dirt, and there's several places you would look for that on a camera. One is around the seams. In other words, if a camera has been even brushed off, it's hard to keep from leaving sand in the seams between, say, for example, the rubber grip along here where my tweezer tips are, and you can see I'm pulling up little grains of sand out of this camera. Also in the film compartment, well, there's a few more grains in here, but normally you'll find sand along these light seams right here. If there are any foam light seals such as this one, they're famous for trapping sand. Also, any place where there's a switch or a button or around the lens area, if you look back inside, you'll generally find a few grains of sand. Finally, take a look through the viewfinder, just as if you were regularly taking a picture. And if you see any spots of dirt or sand in the viewfinder, and you can actually see some in the reflection there, you know that the camera has sand in it. If you see sand in a viewfinder, whether it's a single lens reflex camera or a lens shutter camera, you know that there is sand throughout the inside. Finally, operate the zoom lens, or in this case it's a tele-wide lens, and just listen to be sure that there's no grittiness in the gears and also in the film transport. If you hear any grinding sounds or irregular running, you can be sure there's sand in the gears and it's up against a major repair. The third step in your inspection should be for liquid intrusion or water damage, and these are very common problems with cameras. One of the symptoms is going to be that the camera eats batteries, as the owner would say. That means the battery life is very short, or the camera may have certain parts which don't function, or it may not function at all. This camera looks pretty good again from the outside. There's no significant scratches or dents. It looks clean. Even looking at the front, the lens is clean. Everything looks fine. However, it does have extensive water damage. And the place you're going to look for water damages is on the inside of the camera. Always open the film compartment, because that's something which gets wet. It usually has film in it, which is chemically corrosive when it is wet, and it will leave a lot of corrosion in the camera. For example, you'll see rust here on this metal. You also see signs of sand around the inside of the film compartment, which you didn't see on the outside of the camera. Again, just looking around generally a little more subtly here on the screw heads, you can see rust developing, see the corrosion developing on that screw head. Anytime you see something like this, you know the camera has either been very wet or possibly even submerged. And finally, look through the viewfinder again, the same as you did when you were looking for sand. If you see any spots, any water spots on the inside of the viewfinder system or in the lens system, and you can look all the way down the zoom lens with a flashlight, if there are any water spots or stains, you know the camera was submerged. Any camera which has had significant water damage is very likely a total loss, particularly if it's an electronic camera, and this is an example of one. And we've taken the covers off this camera. Again, from the outside it didn't look too bad, but you can see the extreme amount of corrosion around the inside. Many of the electrical contacts are corroded off or badly damaged. And a camera that's extensively damaged like this one simply is not economic to repair. The fourth and last step of your quick inspection should be for excessive wear. Some cameras are simply worn out when they arrive at the counter, and there are several places you can look for that. One is the release button, particularly if it's a plastic release button, as most of them are now. Normally they have a sort of a sandblast or dull finish to them, and if the camera has been used a lot, for example more than 10,000 exposures, then this will be very shiny around this area. All the texture will be worn off the plastic, and it will be quite shiny in that area. If it is, you know many, many exposures have been made with that camera. Another place to look is inside the film compartment. If there's any loss of blackening right here at these edges, where the edges of the film aperture are, or where the film would turn the corner going to the sprocket. If there's any shininess appears there or bright metal, then you know it has a lot of wear. Also, look for film chips and film emulsion in the film compartment, particularly on the take-up side, here toward the bottom. If there's any film emulsion piling up in here or chips, again, that's another sign that the camera has had a lot of film through it. Any modern electronic camera, particularly those with a liquid crystal display or LCD, are probably microprocessor controlled. And if they are, they have a specific sequence of operation. So testing them is very easy, provided you follow this sequence. And the very first step is, just like a home computer or anything else, when a battery is first installed or they're first powered up, they boot up in some way or another. This particular camera does so by lighting all the LCD characters, and you can watch that happen when I put the battery in. And you also heard a little tweak from the lens as it tested its lens position, and then the 0 and the date come up on the viewfinder back. Now what that tells you is that the microprocessor in the camera woke up, that the power supply is working, and we're off to a very good start. If you don't get that, then the camera has a very fundamental problem, and that is it has a power supply problem. It may be something just as simple as a weak battery or dirty battery contacts. You may have another camera, very similar type of camera, but it has a different wake-up procedure. This one is all audible. You can hear the shutter and then the film motor run. But it did go through a wake-up. And finally, with a single lens reflex camera, this particular one, which is a Canon Rebel, does nothing at all when the battery is put in, but when the main switch is turned off of lock onto the program mode, you will see a display appear in the LCD. In other words, when it's in the off position, there's nothing. When it's on and you see a display, then you know that the processor is awake, and at least the camera, the brains or the microprocessor in the camera are at least functional. Step 2 in the camera's operating sequence would be film loading. That would be the next logical thing that an operator might do. And so what you will do is the same thing, and that is simply open the back of the camera, load a roll of film. When the film door is closed, in other words, when you hear the click of the film door switch, the camera will either load to frame number 1 or pre-wind the film completely to the end of the roll and then count down. Either way, it should go through some type of automatic loading process. There are a few cameras which do not go through the loading process until the release button is pressed the first time. But at any rate, all cameras of this type, the newer modern electronic cameras, will go through an auto load process. We've already seen the APS camera. It does the same thing. It sequences the film and then loads up to frame number 1. If they don't do that, or if you hear any unusual noise in the film motor when that's happening, you can suspect there may be sand in the camera, perhaps a broken gear, or they may have bad switches which are not detecting that the film door is closed. If there's an operator error in film loading, or any type of film loading error, these cameras will tell you that also. For example, let's load the roll of film and not extend the leader far enough for the camera to take it up. When we close the film door and press the release button 1/2 stroke, you hear the camera try to load, and then you'll see the flashing 0 indicating that the film did not load correctly. Most cameras will either flash the 0 or blink the 0 or the letter E indicating empty or air. When you see that flashing, it can be reset by opening and closing the film door. After film has been loaded, the camera is ready to use, so the next step will be to turn the camera on or turn power onto the camera. Now most of them will have either shutters over the lens, as they are here, or some other type of lens cover, as there is in the case of this camera. Normally when the camera is in the off position, the lens is covered or retracted. It'll be pulled all the way in. If we press the power button, the lens extends and the shutters over the lens open up. This camera has a complete lens cover, and also notice that the LCD is blank. When we press the main switch or power switch, the lens cover opens, the flash extends, and now there is information in the LCD. We have the flash mode, the operating mode of the camera, and the frame count shown in the LCD. It's a good idea then, before making any exposures, to test the zoom lens or the tele-wide lens, and we just extend the lens completely, bring it back, do this several times and listen to the lens motor. As long as everything is smooth, you can be pretty well assured that there's no sand or dirt in the camera. However, if you hear grittiness or if the lens is irregular in the way it extends, you might suspect sand damage or impact damage to that camera. If there is any type system error in a camera, they'll let you know that, and usually with an error message, usually the letter E followed by a number or possibly by another letter. This camera has booted up correctly in as much as the battery's been installed, the microprocessor has come to life, we have the 0, but when we press the main switch, in other words to extend the lens and start the camera, a problem occurs in the zooming and we get an error message. We reset the system, installed the battery again, and I'm going to press the power switch one more time. You can watch the lens and listen. And you hear the motor running without the lens moving, which is why we got the error, the E1 message, indicating that the lens did not extend. Anytime you see an error code in a camera, you can reset by removing the battery and starting again. If on your second try you get the same error message, the camera will need service. There are two tests you should make on lens shutter camera autofocus systems. One is to see how it's ranging or if it's finding the right range, and the second is if the lens is actually focusing. And both those you can do visually and very quickly. Most of the newer type lens shutter cameras have LEDs near the viewfinder window. You can see this one. And if I press the release button a half stroke, you'll see that the green LED is lighting in a steady fashion. This is with the release button pressed 1/2 stroke, not a full release stroke, but just 1/2 stroke. And that's saying that the conditions are right for autofocus. In other words, it has found a focus and it's happy with it. If we're inside the range, and I'm going to point the camera towards something which is less than 30 inches away, you will get a flashing or blinking green LED to indicate that it's too close for this autofocus system. If it passed those tests, then you know that the autofocus ranging system, which is located in the front of the camera, in other words, you have the viewfinder window here. The other two windows are the rangefinder for the autofocus system on these type cameras. And you can tell if we do get the normal warning, and you can read in the owner's manual what that should be, then the ranging system is working correctly. The next thing you'll want to do is test the execution of focus or the lens itself, and to do that you will need to make a full release stroke. First of all, you'll want to select an operating mode that turns the flash off, and all these cameras have at least one flash off mode. Next, place the camera on the countertop facing the ceiling so it's stable and stays in the same place. And you may want to hold a target above it, maybe 3 to 4 feet above it, which may be a piece of poster board or a magazine, something that it can focus onto. We've made a white dot for your reference here. And if you check the focus straight above the camera, say from 3.5 to 4 feet away, when pressing the release button, you can see how far the lens turns to focus. In other words, it should focus out to achieve the close focus. Next, I'm going to use my tweezer tips, you can use your finger, and what we want you to do is cover the rangefinder. In other words, the two windows at the top, I can cover those with my hand. This will make the camera think that it's not seeing the IR beam and will focus at infinity, and there should be less motion in the white dot. And now we'll go back to the close focus, and you can see there's a significant difference in how far the white dot travels around the camera. If it's doing this, then the entire autofocus system is working correctly. Testing single lens reflex autofocus systems is actually a little bit simpler than with lens shutter cameras because you can see what's happening through the viewfinder. But first of all, you'll need some type of target, and what I would suggest is a piece of white poster board or white card with a single dot in the middle. This is about a 3/4 inch diameter dot. I've outlined what would be the center of the viewfinder screen. In other words, most viewfinder screens have a focusing area outlined on them. And what you want to do is put that focusing area right over the dot and then make another shot with the focusing area away from the dot. In the one case, the camera should focus and fire. In the other case, it should not. I'm going to just pick the camera up and aim at the dot, and you'll notice we came into focus and the camera fired. Again, now I'm going to move the camera just a little bit so it's focusing away from the dot, and you see the lens hunts and goes back to infinity, and I cannot cause it to release. Pressing the release button causes no release. If the dot is sharp in focus in the viewfinder when the camera focuses on it, and if the camera focuses and releases when the dot is centered in the viewfinder screen, then the autofocus system is correctly aligned and working well. Also, the camera should hunt or not release when the dot is not in the center of the screen. You can also change to manual focus and manually focus most single lens reflex cameras, the autofocus variety. Then, while looking in the viewfinder for the focus, you will probably see a green LED turn on to indicate correct focus has been achieved. This is a good way to check the accuracy of the focus system. If an SLR camera has problems with autofocus, if the focus, for example, is erratic or takes a long time, there may be a very simple problem, and that is just a little bit of dirt on the lens or on the mirror. So remove the lens, look at the back element of the lens to be sure it's clean, also the front element. If the camera has a filter over the lens, take that off and try the autofocus. It may work a lot better without the filter. Be sure the filter is clean, and be sure the reflex mirror is clean. After doing all those, if you're still having problems, there may be some dirt on the submirror or on the CCD underneath the submirror. That's probably better left to professional training. Testing exposure systems on single lens reflex cameras is relatively easy because most of them display the exposure. First of all, the metering system should respond to changes in light, and that should be displayed when one presses the release button a half stroke. The display shows a 90th of a second at f2.5. If I cover the lens with my hand, that drops significantly, which indicates that the metering system is working. You should get some type of response when you go from light to dark. Sometimes it will require a second press of the release button, depending on the camera. Next, you'll need to make some exposures, first pointing to bright light and then to dim light, and just see what happens, particularly with the diaphragm. If we point towards some bright light and make some exposures, you can see the diaphragm is stopping down. And then if we point away to where it's darker, there's almost no stop down of the diaphragm, so that you know the exposure system is working. If we cover the lens, you should hear the shutter give a slow exposure, and you can hear the actual exposure slowing down. Testing exposure on lens shutter cameras is quite simple because they have auto flash or automatic flash for dark situations. And if the mode is selected, and it is here, in other words, we've selected auto flash, it should do just that. In other words, if we darken or point the camera toward a dark area, you can also cover the light detector on the front of the camera. But if we point the camera toward a dark area, it should flash during an exposure. If we point the camera toward the lights, it should make an exposure without flash. If it's doing that, the metering system is working on the camera. Finally, you should test flash mode operations, particularly on lens shutter cameras. Most of the modern lens shutter cameras offer a variety of flash modes. For example, we can toggle through these on this camera. That's auto flash, red eye reduction, fill flash, which means the flash always fires, and flash off. Now, we've already tested the flash off mode. We've tested the auto flash mode just a moment ago. So let's go to red eye reduction, and normally what that does is fire several small flash bursts prior to the exposure. So we'll press the release button and watch the flash. Notice that there were 2 pre-flashes, followed a short time later by the full flash. And finally, moving over to fill flash. That simply means the flash should fire at all times. So if you point the camera toward the lights or a bright light, the flash should still fire, and it does. Cleaning a camera is an important service, and it's something that can be done easily without too many tools. You'll need a few supplies, and not expensive ones at that. What we have here is a small bottle of isopropyl alcohol, and you should use either 91% or 99% isopropyl. Those are both obtainable at drugstores. Do not use the 70% rubbing alcohol. Be sure to go with the 91 or 99. A hand blower of some sort. This is just a little compression type hand blower. A stiff brush. Toothbrush is fine. You'll need a soft brush, and an artist paint brush works well for that. I usually cut the handle off to make it more manageable. Some cotton swabs, a soft lintless cloth, and you'll need some type of lens cleaner. You can use a commercial lens cleaner, or you can make your own. This particular lens cleaner we're using is 50% isopropyl alcohol, 50% Windex. We'll show you the formula for that on the next graphic. Next, we're going to use a single lens reflex camera to demonstrate some of the cleaning you should do. The same would apply to a lens shutter camera as does to a single lens reflex. But the first step is going to be to go over the camera with a stiff brush and take away any dust or sand. And for that, you're going to work, inside the lens rings. Don't touch the glass with a stiff brush. Also get along the edges here between the seams where the lens joins the body. Any place there's a seam or a control button where sand or dust can gather, just clean those out. Just brush around the camera, and then move into the film compartment. And again, where you can, either with a stiff brush or it's a little easier with a soft brush, just get in, brush out any dust. It's very important to have a clean film compartment, so you want to brush the dust out of there, brush out any emulsion. Take a hand blower, and you can use canned air for this also if you want to. And always take care not to touch or direct air pressure against the shutter. Don't forget the pressure plate. Use a soft cloth. Wipe the fingerprints off the pressure plate. There will usually be some on there. Look for any scratches or any dents in the film pressure plate. Also, while you're in there, check around the light seals, like any of the foam. Make sure there's no deterioration in the foam around the film compartment, because that can cause light leaks. Next, you'll want to clean some of the glass, and to do that, if you have a dropper bottle with a lens cleaner, put 3 or 4 drops onto a cotton swab. Make that so it is wet, but not just dripping wet. In other words, I'm going to just put a little bit onto the mirror here, and as I touch the cotton swab to the mirror, you can see it leaves a damp or wet spot, but it doesn't just drain out all over the place, because you don't want to flood the lens. You can start with the front element of the lens, start in the middle and work in a circle all the way to the outside. Then turn the Q-tip over, or the cotton swab over, and do the same thing with the dry side. You can rotate the cotton swab as you're doing this to always keep dry cotton exposed to the lens, and simply polish the lens. Now you can see I'm moving the moisture around there. It's beginning to dry up. I'm going to take a fresh cotton swab and finish polishing the lens this way, and all the way around to the outside edge, and the lens should shine. If you blow your breath on the lens like that, it should make an even fog, and you can see there's still a few streaks, so you'll want to polish until those streaks are gone, and you will have a perfectly clean lens. Don't forget the lens has 2 sides. There's a front and a back. You can clean the back side also. One of the most important lenses on the camera is the eye lens. They're almost always dirty. You get face oil from eyelashes and so on against them. Also, they're great accumulators of dust and dirt. So you'll want to clean those, and again you can use a damp cotton swab, then a dry one. Move in again, working to the edges and getting all the corners cleaned out. The customer will really appreciate this because that's going to brighten the viewfinder a great deal. Look at the reflex lens in the film or the mirror compartment here. This particular one is fairly clean. If it's filmed over or very dusty or very dirty, you may, using a hand blower only, blow lightly against it to blow dust away. Do not use canned air inside the mirror box because you'll blow dust up into the viewfinder if you do that, and there'll be spots all over the inside of the viewfinder. Also, do not touch the viewfinder screen. I'm pointing toward it with the cotton swab here, but this area that I'm pointing toward is a soft plastic Fresnel lens. It's very easily scratched. If it's dirty, leave it dirty. Do not touch it. Leave that for professional cleaning. If you need to clean the mirror, you can clean it the same way you clean a lens, and that is with a few drops of lens cleaner on a cotton swab. And then I'll try to get the light angle here so you can see this. We'll just lightly wipe the mirror from side to side. Be sure you get a nice coating of moisture on it, or lens cleaner. And then again reverse the cotton swab, going to the dry side, and just lightly polish. You won't scratch the mirror as long as you use clean cotton swabs. And work around all the corners. Polish. There may be a slight blue haze that you'll see. Just polish until that disappears, and then the mirror will be clean. Next, you'll want to look at the battery contacts, and in this camera, this particular camera uses a 2CR5 lithium battery. The battery contacts then will be quite high up inside the compartment. You notice most of them are nowadays stainless steel, so they don't tend to corrode so much, but they will sometimes get a little bit of dirt or a film on them that prevents good battery contact, and you can get erratic operation. So again, we can clean those using a cotton swab. We use just a little bit of isopropyl alcohol. Remember, this is 91% isopropyl. And then just go inside and carefully wipe off the ends of the battery terminals. If it looks like that there might be something on there which is giving you a little bit of trouble, you can break a Q-tip and use just the paper end. In other words, the frayed paper makes a pretty good cleaner, and you can work that against the battery terminals and usually take off any stubborn films that are on that way. Also, while you're cleaning and checking the camera, take a good look at the shutter curtains. They're quite often a source of damage from finger damage. When the operator is loading the film, sometimes they will touch the shutter curtains with their fingers and actually either put dents in them or push them through sometimes. So take a good look at those, make sure they're not bent. If there's any stains or oil or anything like that on the shutter blades, you should not attempt to clean that. You should leave that to professionals. The final step in your service should be to check the battery, particularly if it's a lithium battery. They do need to be tested, and the camera simply will not work if the battery is low, or will be erratic if the battery is low. You can use a tester such as a ZTS lithium battery tester, and we'll just run a quick check on this lithium battery. As you can see, it's in very good condition. It's lighting all but the top green LED. But battery testing is extremely important, particularly with lithium batteries and the new electronic cameras. If a camera comes in not working, always suspect the battery first. And it's important, particularly with lithium batteries, that they be tested on a battery tester which is rated for those lithium batteries. A conventional battery tester will often test a lithium battery good when in fact it will not operate the camera. This concludes this videotape, which has covered film formats, camera types, inspection, operational test, and minor service.